Hello there, I'm Thomas Hatsios, German-American pilot flying the Boeing 787-900 to nice flight. We're going to be flying Zurich, Switzerland, Germany, then coming back to the Zurich International Airport, runway 14 Lszh, localized and landing. So right now I'm in the cockpit for the pre-takeoff preparation of the quality wings, Boeing 787-900 and Microsoft Flight Simulator X. I'm going to start showing you the cockpit instruments and displays and the functions of the Boeing 787-900 aircraft. I'm gonna start with the primary flight display that displays the airspeed indicated, the airspeed selected from the autopilot and flight director system panel, the ground speed, the radio altitude above the ground level, the barometric altitude above the sea level, the target altitude selected from the autopilot and flight director system panel, the barometric pressure of the outside atmosphere, the vertical rate of climb descent of the aircraft in tens, hundreds, and thousands feet per minute, the steepness of the trigonometric compass in the sinking incline and descent. We have also the altitude indicator with the pitch ladder decrease and the bank angle in decrease, the artificial horizon. We have also the Lszh localizer, the horizontal localizer and vertical glide slope that receives the radio frequency transmitted from the threshold antennas of the runways we use for takeoff and for landing. So we can tune a unique radio frequency for either runway we use for takeoff and for landing and set the magnetic north pole heading for this runway. So we will receive from the onboard antennas of the aircraft radio frequency will display the horizontal localizer and vertical angle of approach for the Lszh localizer, the instrument system of the airport. We have the Lszh localizer crossbars also displayed in the primary flight display, and the flight director crossbars for manual guidance of the aircraft, and the autopilot crossbars for automatic guidance of the aircraft. We have also the angle of attack of the aircraft as it flies, the flight mode and zero with the autopilot and the auto throttle, lateral and vertical indication modes, and also the HSI, which is the horizontal situation indicator. It displays the magnetic heading and track, and also the display of the flight plan we're gonna create. You will see in the integrated display the flight plan line displayed with a purple magenta line. We can see also that we have the navigation display. The navigation display that displays the horizontal and vertical profile of the aircraft as it flies. You can see the terrain weather reflections from the weather radar displayed with red, green, and yellow or amber color. So you can see, depending on the distance, the elevation of the terrain, the mountains around you, and the valleys below you, so you can fly the aircraft more safely in a low visibility condition. You can also have, you can see the navigation display. You can see also the terrain map with the airports where they are located. You can see our own airport, the runways we're gonna use for takeoff and for landing, the runway length, and the taxiways we're gonna use also. We have also the VOR stations, the ABFs and the NDBs, which are the navigation aids, the nav aids. Also the waypoints which are horizontal and vertical navigation fixes, and altitude and airspeed constraints. We're gonna select many waypoints later from the flight management computer, the FMC. So you will see how we're gonna set up a flight plan with a departure airport and a destination airport. We're gonna select the same airport and the same for departure and arrival, and the same runway. So we're gonna save time for the video record like this. So we have also over here, you can see the terrain map. You can see the magnetic north pole and the geographic north pole magnetic variation depending on where we are in the world. We have also the display of other aircraft around you when you fly using the transponder, the DSP and AC transmitter receiver transmits our frequency to other aircraft and the air traffic control, and receives from other aircraft. You can calculate the other aircraft distance and bearing depending on with our aircraft. Its location and distance. You can also calculate how many hundreds and thousands of feet the aircraft is above or below our aircraft. It will display in the navigation display all the information we need. Also, you can calculate whether the other aircraft climbs or descends with respect to our aircraft. You can also show you can calculate the velocity closing in between our aircraft and the other aircraft. It will give us a warning from the TCAS system, the traffic collision advisory system. In the area we have an incoming collision. It displays also all the aircraft we need to see up to 40 nautical miles, like 72 kilometers away from our aircraft. You can display other aircraft in the air. also in the ground, in the runways and the taxiways of the airport, so we can see the other aircraft where they are located. We will make an avoidance maneuver in the air, so it displays a diamond shape of the aircraft around you. So we have also um, in the navigation display, you can see we have both horizontal and vertical profile as we fly over here. You can see also the primary flight display, the engines indications, the flight management computer. I'm gonna use to create the flight plan, the autopilot, flight director system panel, the thrust levers, also the yoke that controls the flight controls of the aircraft for the Boeing 787. Hope you like the Boeing 787 aircraft and functions. I will show you all the functions of the aircraft before we go into flight. Also the overhead panel, the electric, hydraulic, fuel system, engines, auto start system, engine control, pressurizer and cabin pressurization, oxygen for the aircraft, also air data computer, primary flight control computer, some other functions over here. So we're gonna see all the systems also displayed in the display over here. So I will show you all the systems, the primary flight display, the navigation display, the engines indications, the thrust levers, also the flight controls. I will show you how to control the aircraft using the flight controls. I have this computer here right now. I have also the mouse pad. I have the keyboard to input whatever I need on the screens of the computers of the aircraft or the autopilot settings. I have also this to control the flight controls of the aircraft over here. It's identical to the Airbus aircraft side stick, so you can climb and you can descend the aircraft up and down, back and forth, very easy. Also make turns left, right and left over here using the control wheel. You can use also the rudder pedals for directional steering of the aircraft in the ground or in the air. So we climb and we descend. We use the horizontal trim stabilizer to balance the aircraft in the air. So I will show you how to control the aircraft using its flight controls. We can fly very easy. So also use the outside view. I will explain you some principles we need to know for flying the aircraft. First I'm gonna show you the displays a little bit, then I'm going for the principles of the flying for the air transport pilot license, the commercial pilot license. So you can see here we have the primary flight display. You can see the airspeed indicated. It's from the pitot dynamic tube. Over here we have the air data computer. It controls the air data, pitot static, pitot dynamic. Pitot dynamics for the airspeed, pitot static for the altitude. Also the difference of altitude, we have the pitot cube. We have the airspeed indicated right now. The airspeed selected from the autopilot flight director system panel. You can see the airspeed we have selected is pre-selected from the aircraft. We will change the values later. It's 200 knots, 360 heading, 10,000 feet over here for the altitude, 10,000 feet above the sea level. Barometric pressure, altitude, also the vertical rate of climb descent of the aircraft. This switch over here, autopilot over here, engage and disengage switch. You can pull down this slider over here and you disengage the autopilot. We have also the LNAV. You can change the value over here. So I will leave this right now at 200 for the moment. So we can see we have other switches. So we have the airspeed indicated. The airspeed selected from the autopilot flight director system panel with purple. The radio altitude above the ground level. It will display up to 2,500 feet here, and also will display more than 5,000 feet in the navigation display. In the vertical display, you can see also we have the barometric altitude 1,400 feet. This tape. The altitude selected from the autopilot flight director system panel The vertical rate of climb the center of the aircraft in tens, hundreds, and thousands feet per minute. You can see 500, 1000, 1500, 2000, 3000, 6000 feet per minute for climb and descent. Also, you can see the pitch ladder in degrees over here, like 2.5, 5, 7.5, 10, 12.5, 15, 17.5, 20 for pitch up or pitch down. Also, the bang roll of the aircraft. When we fly, we can bang roll like 5, 10, 15, 30, 45 degrees, either left and right bang rolls. You will see the slip indicator, also for the side slip. So this is the pitch ladder. You can see the wings level symbol over here. This black lines is the wings level of the aircraft. This is the flight director, the crossbars we have to follow. It's whatever we tune in the autopilot panel or the flight management computer inputs we make. It will show us like the ILS localizer or other. That I will show us here. You can see flight director right now displayed, FLD DIR, and takeoff grounds for flight mode annunciator. You can see here XPDR, CELCAL, tail number, other information. So we have here heading, the heading of the aircraft, ADF left and right, the stations we have tuned for alignment of the aircraft. You can see also the navigation display. You can see the terrain with amber or red color over here, 1600, also yellow and green, also blue for the lakes, rivers and sea. So we have the indications right now. You can see the Düsseldorf airport EDTL over here. This is Düsseldorf. It's the same alignment, 331 magnetic north pole is in front of us. If we fly straight, we'll go to Düsseldorf like 60 nautical miles away from us. Right now the range is 80. So you can see also Lszh airport over here. So here is the Germany, this section over here. If we increase the range of the map, you will see Germany over here, German airports, also the France and the Switzerland. The elevation of the terrain, it changes, 4,800 the red is the maximum, 1,600 the minimum. Display with the red and amber colors. So if we will look closer, you will see more mountains closer to you, like 10 nautical miles, 5 nautical miles over here. You can look over. You can see the aircraft when we fly. Right now 1,400, the aircraft symbol. We can fly this elevation we have selected. So if we look further away, you will see a little bit more of the map display. 20 nautical miles, 12,000 feet. So you will see different displays later for the navigation display. Also we can display other data, you will see. So we have the barometric altitude here, 1,430 feet. Also we have the barometric pressure, 29.92 inches of mercury is already radio minimums, 200 landing altitude, no V speeds. So we have 29.92 inches of mercury. We can increase or decrease the value to change the barometric altitude depending on the airport air traffic control request. So we have inches of mercury or hectopascals, 29.92 inches of mercury or 1013 hectopascals for the barometric pressure, which will display this altitude over here. So you can see we have this altitude, 29.92 inches of mercury, 1,430 feet. So we can increase and decrease also the range, the plan, change the view, weather radar, traffic, terrain, also radio or barometric minimums. So remember inches of mercury, hectopascals, flight path vector meters in the display. So this will give us this correct barometric altitude over here. Also accept, cancel, reject the warnings displayed here. We have some systems display, system, CDU, info, checklist, communication, navigation display, ACAS for the engines indications, left and right multifunction display. Also expand, the map view, like in the right side over here we have the full map view, not the engines. We can select whatever we like, so you can see the full map view like this, an extended map view like in the Boeing 737 MAX model. So this is the Boeing 787-900, similar screens and displays like the Boeing 737 MAX. So we have also the flight management computer. I will show you how to control the inputs using the mouse pad here. Also the screen here, you will see the keyboard. I will use the values, the alphanumeric values, and select the modes we need to set up the flight management computer. Have also the mouse pad here. You can see the thrust levers. I can move forward enough over here using the thrust levers control. You can set the percentage of the thrust needed for flying the aircraft. So you will see we increase the thrust up to a takeoff go round mode. Will give us a warning over here, will not configure for takeoff. You can see also the position of the thrust commanded and the actual thrust. It takes a few seconds to increase or decrease. And 1 exhaust gas temperature, and 2 fuel flow, oil pressure, oil temperature. Over here oil quantity, and the vibration of the N2 stage of the engine. It's displayed from the FADEX, the N1, as you can see, and 2. Also the cabin pressurization here, which receives usually pressurizer from the engines. With the 9 stage, you can see cabin altitude right now, rate of climb descent, differential pressure, DP, and landing altitude, forward and aft the outflow valves. You can see also gross weight over here for takeoff, and the total fuel on board, fuel temperature right now. So you will see all these things will change when we fly. We have the landing gear here, extend and retract. We can pull up the landing gear. The auto brakes also over here. Set the auto brakes, as you can see. Auto brake 1, auto brake RTO. So we set to the off position. We have also the alternate gear and the lock override over here. The extend and retract speeds for the landing gear, stabilizer trim, horizontal tail trim, stabilizer rudder trim, and the flaps position. We can set different flaps position as we need for flying the aircraft, change the airspeed and the altitude of the aircraft in flight. So we have also the horizontal trim stabilizer over here and here. For every aircraft we can trim the horizontal tail of the aircraft when we fly. This is a fly-by-wire aircraft. It has its flight control computers. So when you move the yoke on the Airbus aircraft, you have the side stick. You give a command to the flight control computers in the air, depending on the mode you are, like in the flight mode or the ground mode or the roll mode. So we have the normal, the alternate, and the direct mode of the flight control computers, both in the Boeing and the Airbus aircraft. Also we have the mechanical backup. So you can see here we have the flight control computers in the auto position. It's only one switch in the Boeing. It's not like many switches in the Airbus. So you have the primary flight control computers. Also we have the air data computer here, and the flight control services. So when this is on, controls the aircraft in flight, the flight controls when we move. It makes corrections for the G loads, like in the Airbus aircraft in the air. So we move the flight controls, you will see. So we can climb and we can descend, side stick up and down. Also ailerons, spoilers like this. Very easy, very fast. So I will talk to you about the horizontal tail trim stabilizer over here in a couple of minutes. You can see we can trim when we fly the horizontal tail of the aircraft like this. So this way you trim the elevator up, and this way you trim the elevator down. when flying, like in every aircraft. Some aircraft have the trim wheels, some have the suites. So you see elevator trim, left click down, right click up. This tag reads elevator trim, left click down, right click up. So you trim up the elevator this way. You pitch up the nose of the aircraft. When you fly, you have this aerodynamic effect, and when you trim the elevator down, you pitch this way the nose down of the aircraft as you fly, to help relieve the air pressure from the yoke from the elevator. So you see how many degrees you have nose up and nose down in the stabilizer trim over here. You can see the green band is for takeoff, this setting. So we trim up and trim down the elevator like this. We have also a couple more switches here. We have the autopilot disengage switch, the head-up declutter. Also, you can see the flap speeds here. So usually we use this trim switch to balance the aircraft in the air when flying. Also, we have the alternate. This was the normal flight control computers channel, the manual trim switch. This is the alternate trim manual switch, the alternate flight control computers channel. So we trim up and trim down, nose up. This way you trim the elevator up, you pitch the nose up. This way you trim the elevator down and you pitch the nose down. So we use nose up or nose down like this. Very easy to remember. So again, it displays here how many degrees. We have also other things. We have the parking brakes over here, on and off. We have the cutoff switches for the stabilizer trim for the Boeing aircraft. You can see reads cutoff, the tags stabilizer L2 stop, cutoff switch guard, and R2. So this is for all Boeing 737 aircraft, Boeing 747, Boeing 757, Boeing 767, Boeing 777, and Boeing 787. If you have a failure of the hydraulic systems, you can see here we have the hydraulic system that will affect the flight control computers. It will degrade the mode, primary flight control computers. We're gonna lose the auto trim function. Also, maybe the autopilot flight director system panel will be affected, and the auto throttle. So we're gonna have a degraded mode. This is for all Boeing aircraft: Boeing 737, Boeing 747, Boeing 757, 767, 777, Boeing 787. You open from normal to cut off, and you disengage this stabilizer trim function. You have only the alternate. You lose the automatic trim, the auto trim function of the aircraft, because this fly-by-wire aircraft can trim itself when you fly. You keep having the manual trim switch all the time here, as you can see. So you keep trimming manually. In the air also we have the alternate and the alternate channel with the flight control computer speed string. So this is maybe more similar to the Embraer or CRJ aircraft. So this balance the aircraft in the air. I will show you now the flight controls of the aircraft. You can see again the setup, the computer, the side stick I have. So I will talk to you about the Newton's physics, aeronautical, aerospace engineering, and derive you some principles we need to know for flying the Boeing 787 aircraft. We need to know flight dynamics, aerodynamics, and aerospace engineering for the air transport pilot license and the commercial pilot license, the Bernoulli theory of fluids, and the Newton's physics. So I will show you the principles of flight, the flight dynamics. So I will show you now outside. You can see, so we have the wings of the aircraft. When the aircraft is flying, hold the weight of the aircraft, and we divide the weight of the aircraft over the surface area of the forward wings mainly, because this holds most of the weight. We have the thrust vectors from the engines, because it's a jet airplane. The propulsion from the engines that moves forward. You can see the high pressure compressor and turbine in the back of the engines, and also the low pressure compressor and turbine in the front. The low speed starter and shaft and the high speed starter and shaft, the exhaust cone, the jet blast, and also the bypasser over here. We have also the fuel lines in the top that feed the jet engines with fuel from the left wing and the right wing tanks and the center tank. So we have the fuel booster pumps. We have 30% of fuel in the left and the right wing, 10% in the center right now. I have loaded that way. So we can see also we have the mean aerodynamic chord position, the Mach, which is 23% of the mean aerodynamic chord of the forward wings, where the maximum aerodynamic lift occurs in the flight. Also the center of pressure is moving back and forth, where the mean aerodynamic chord is. Also is the position where we calculate the center of gravity, is the yawing axis also of the aircraft, the center of gravity over here. So to use the center of gravity, you use the rudder to make left over here or right turns. You can use also the nose wheel steering in the ground. We can use the forward nose wheel. Depending on the airspeed of the aircraft, you can make left and right turns 76 degrees, either left or right side, using the rudder again pedals together with the rudder control we have over here in the rudder pedals. The rudder, the vertical stabilizer, and also we have make left and right rudder. We have also the nose wheel steering, left and right turns. Both sides are interconnected, move together. There's no difference in the deflection. Also we have the tiller only for the nose wheel steering. So we have also the toe brakes in the top surface of the aircraft. They are identical with the Airbus aircraft, both the Airbus and the Boeing rudder pedals control. So we control the nose wheel steering and the rudder. We control the nose wheel steering over here 76 degrees from 0 knots up to 45 knots. We deflect 76 degrees either left and right turns using the nose wheel over here. And we have the rudder also a little bit aerodynamic effective, is becoming above 45 knots when the computer decreases the deflection automatically of the forward nose wheel from 76 degrees to like 7.6 degrees left and right. We have the aerodynamic effectiveness of the rudder above 45 knots or 72 kilometers an hour. It decreases automatically from the computer, the forward nose wheel. So as we increase the airspeed for takeoff above 80 knots, 70 or 80 knots, like 144 kilometers an hour, the computer deflects, locks the forward nose wheel to zero deflection over here. We have only the rudder to control the directional steering. In takeoff or in landing, the inverse is happening. As we decrease the airspeed, we have the forward nose wheel activated. So we have the rudder to control the aircraft. So we have the rudder above 80 knots or 144 kilometers an hour. So also we have over here, you can see we have this axis, the lateral from wingtip to wingtip. It's the pitch axis. In the Airbus we use the SASIC back and forth to make the elevator, the horizontal tail of the aircraft, or horizontal stabilizer elevator to climb and descend the aircraft, as you can see. So the Airbus back and forth, the elevator up and down, you pull up the weight or you pull down the weight of the aircraft. Also we have the horizontal elevator trim function that I show you in the trim switch. I have the trim switch here. So we climb and descend, we have the elevator here. It is the yoke, the control column of the Boeing aircraft, the vertical column. for controlling the elevator back and forth, the side stick back and forth in the Airbus, no difference, same function, same flight control movement. So you climb like this, you can see how many degrees you climb descent, also in the primary flight display, the pitch attitude of the aircraft, so you don't need. Also you have one more axis over here. We have from nose to tail is the longitudinal axis of the aircraft, which is the side stick left and right in the Airbus. You make left and right turns using the aerodynamic difference between the left and the right wing, the ailerons and the spoilers. In the Airbus aircraft also is ailerons, spoilers and flaperons in the Boeing aircraft, in the Boeing 787. So same flight controls, climb, elevator, ailerons and spoilers, left and right turns. In the Airbus and the Boeing, same flight controls, the rudder, nose wheel steering. So you can see also in the Boeing aircraft we have the control wheel to make left and right turns, no difference from the Airbus aircraft, same flight control principle. So we have full flight control together, aileron, spoilers and elevator the tail, coordinated flight controls in the air, you will see later. Also you can see the captain and the first officer in the Boeing aircraft are interconnected and move together. Unless you have a failure or you want to override either side, you use some force from either side. In the Airbus you have the side stick priority, you can use either side stick with the priority button. Also in the Airbus you have the autopilot disengage here and now the push to talk button. Also you have dual input in the Airbus aircraft unless you use this priority side stick button. So this is most of the flight controls. Also you can see we have the bottom surface of the wings over here, it's more flat and the flaps are extended for the aircraft flying. As we increase for takeoff we have positive angles of attack or falling. The airflow is moving slower below the wings, which pressurizes the wings and the weight of the aircraft up into the air. So this is for the airplane flying. Also the top surface of the wings is more curved, so the airflow is moving. You can see an aircraft coming, Boeing 737. So the airflow is moving faster above the wings over here. So we have lower air pressure, which sucks the aircraft up into the air. When we reach the takeoff speed in the air, 140 knots or higher for this aircraft, like 250 kilometers an hour, we need to produce the aerodynamic lift in takeoff above that V1, V2, V rotate speeds. So this is for the flight controls. I will show you a little bit more for the flight controls now. So I will show you now one more view of the Boeing 787 flight controls system. Then I will set up the flight management computer and make a complete flight from takeoff, climb, cruises and approach and landing in the end part of the video. Stay with me until the end part of the video to see the complete flight. So also another view of the aircraft, how I use the computer and the flight controls here. So hope you like what I'm doing here. So you can see we can climb and we can descend. Again, we have one more nicer view. Now close up a view of the side stick like this. So you can climb, you can descend very fast. Make turns to the right, make turns to the left like this. Like the Airbus and the Boeing flight controls are pretty much similar. No difference at all. So we climb with descent like this. Make turns to the right, make turns to the left. Also horizontal trim stabilizer. So we use the thrust levers over here to increase and decrease the engine's thrust. As you can see, we will see later in flight. So you see the thrust levers position here. So hope you like how I use the side stick, which is identical to the Airbus side stick over here. Climb descend, make turns to the right, make turns to the left. So I'm gonna show you here the outside view of the aircraft, so we can climb and we descend, make turns with the rudder right and left. Ailerons and spoilers here, left and right turns. So we climb and we descend like this. So now I'm gonna show you how we're gonna input the data we need from the flight management computer. So we will input all the data for this flight. The takeoff gross weight of the aircraft, that includes the anti-weight plus the passenger plus the cargo plus the fuel on board, with the fuel is on the left and the right wing in the center tank. How much we have, 30% in the left and the right wing, 10% in the center tank. The flight management computer is gonna calculate the center of gravity and the mean aerodynamic chord for flying the aircraft. From takeoff, climb, cruises and approach and landing. As we fly, we burn fuel also with same altitude in flight. So the flight management computer recalculates the center of gravity. We have many computers in the aircraft. Also for the flight controls, for the fuel system, for the autopilot, flight director system. So we're gonna have also the mean aerodynamic chord position. The flaps, we're gonna use 15 degrees of flaps for takeoff. We're gonna use 4.25 degrees of horizontal tail trim stabilizer for takeoff. Also the takeoff speed, we're gonna select the runway. You can see the runway here, the runway 14 in the Zurich International Airport. The runway length, the runway slope, the wind direction, speed, the barometric pressure, the density of the air. We're gonna use full takeoff thrust of 99 to 100%, 15 degrees of flaps, and 9 degrees of pitch attitude rotation in flight. So we're gonna have the seats. The seats are instrument departure waypoints and fixes that include horizontal altitude and airspeed constraints. For the initial climb, departure of the aircraft, we're gonna climb to the cruise level to 85, 26, 27, 28, 29, 30,000 feet above the sea level. We're gonna cruise, make some turns. We're gonna initiate the descent back to the airport, like 7 or 6,000 feet above the sea level. We're gonna be aligned with the stars. The stars are the SAR terminal arrival waypoints and fixes, the long final and short final approach fixes, and airspeed and altitude constraints. We're going to be aligned also with the magnetic north pole heading of 136 degrees. For the runway we use for takeoff and for landing. Also we're going to use the Lszh localizer, the instrument landing system of the airport that transmits radio frequency from the threshold of denotes that are received from the onboard denotes of the aircraft. Will be displayed in the localizer and the vertical glide slope. The Lszh system and the crossbars, we're gonna have 25-30 degrees of flaps extended for approach and landing, and airspeed 160-170 knots, like 270 kilometers an hour, and also the landing gear extended and a pitch attitude of 9 degrees or less for touchdown. So you're gonna see now, I'm gonna set up, I'm gonna use the flight management computer here, the keyboard also. I have my own keyboard over here. I'm gonna set the autopilot so you will see. Using this mouse pad we can control the display here, so we can use identity position, performance, takeoff, approach, enunciate status, flight plan, navigation, data, alert to traffic control, safe flight plan. We have many modes. So also, this view over here. So we're gonna make it a little bit more fast. So you see the identity is a Boeing 787 aircraft, the NX engines, the Iraq cycle, the position, Lszh airport over here in Switzerland. Lszh. Also we can align the inertial reference system. We have the performance, zero fuel weight plus fuel on board, the gross weight for takeoff, reserve fuel, cruising altitude, cost index, fuel freezing temperature. So we said first Lszh, the origin and destination airport. We're gonna select same for this flight. We select also runway 14 over here. We clear the screen and use runway 14. So we select departures and arrivals. Departures runway 10, 14, 16 over here. 2834. We select runway. Departure arrivals, departures, select runway 14. So we have the seats, the other instrument, departure waypoints and fixes over here. The Zui to Alpha we select. We go back, departure arrivals. We can select approaches, runway 16 to 8, 34 ILS, 14 ILS, 16. ILS 28, ILS 34, GLS 14, localizer 28, localizer 34. So we select ILS 14, Trans Amiki over here, and the stars, the other terminal arrival waypoints and fixes. We use Negria 1 Alpha. So we have the legs. The first, the route is not yet activated. It's displayed with blue. We have the first waypoint after departure. Cruise to the Zui, cruise altitude, descent, approach, and landing. So we set first the reserve fuel over here, and the fuel on board with the zero fuel weight and the gross weight. Cruising altitude 25,300 feet, the cost index 100%, and the fuel freezing temperature, cruising center of gravity. We go to the legs, press the execute button, which will activate. It will display with purple and white. So we have the first waypoint, 136 degrees to nautical miles, 215 knots on 1,900 feet above the ground level. Make left turns here for the Zui, 1356 nautical miles, 250 knots, 6,000 alpha, heading 052. Nigria heading 071, 26 nautical miles from Zui, 250 knots, right level 23,900. We make a right turns to the Matic, 12 nautical miles, and descend for approach and landing 250 knots, 11,000. Zui, Transmative, Amiki, 1269 nautical miles, Zurich 701, 6 nautical miles, 180, 6,000 alpha. We make a left turn here, Osnem, align with the runway 5 nautical miles, 170, 4,000 feet, and runway 14, approach and landing. So this is the flight plan. We use 15 degrees of flaps, center of gravity, automatic, clear over here, and the takeoff speeds V1 we rotate, and V2 gross weight for takeoff. So we have departure arrival, alternate VNAV progress, FMC communications, hold over a waypoint, fix navigation radio. We can tune ILS localizer. So we go back in the virtual cockpit. So we can tune over here the last things we need to do. We can use the APU, the auxiliary power unit, to start the engines of the aircraft. You can see we have here the left and the right engine driving IDZ, 120 200 volts, 400 Hz frequency. It's the left and right engine driving, 120,000 kilovolts. The batteries, primary flight control computers in the auto, air data computer, flight control surfaces, battery, FD door over here, towing power, passenger oxygen over here, window heat, ram air turbine over here. Also we use in the off position the hydraulics. You will see what it displays some fault, so we turn back to the on, the primary command, the engine driving, and then to the auto. We have also the wing and engine the eyes over here very quickly. We have also the air conditioning pressurizer section over here for the packs for cabin pressurization, also for wing and engine guard the eyes for the hydraulic fluid tanks. Also in the manual we use the outflow valves when we climb and descend to pressurize or depressurize the cabin, so we use the auto position. We have also the recorders, the cargo and APU fire extinguishers, the electronic engine control for the engines with the auto start mode over here, the normal and the alternate mode of the engines that control the fatigues. We can dump some fuel to make an emergency landing, fuel jettison, select the nozzles and how much to remain. Also we have the left and the right wing fuel tank, the center tank, the fuel booster pumps, also the crossfeed valve with turn-on can feed either engine with either pump or either tank and balance the fuel between the left and right wing. So this is the fuel tank and valves, and also most of the overhead panel, whatever we need to know and do. So we go over here. One last thing, the systems display. You can see the flight plan we have created over here. So we go in the systems over here. So you can see we have the hydraulic system over here. The APU is running, oxygen, liquid cooling. Also we have the electric system, left and right drive for the integrated drive generator, 120 to 100 volts for 100 frequency. The APU is running, the load set, and the battery voltage over here, and average main and battery and APU battery. The hydraulic system over here with the hydraulic fluid goes, primary demand, it's driving electric C1, C2, isolation valves, the pressure 5100 psi system, and the quantity of the hydraulic fluids, the fuel system, the left and the right wing and the center tank, the left engine, right engine. So we have also the minimum fuel temperature over here. So you can see we have 11,000, 11,000, 11,000, total 33,900 pounds. The long high pressure fuel valves, left and right engine, open and feed both engines. The crossfeed valve we would turn it on, you can feed other engine with other pump or either tank, the crossfeed. Also the APU is fed from left wing using the DC motor. We have also the minimum fuel temperature over here. As you can see, minus 37 degrees, below which the fuel temperature, the fuel will freeze. The fuel temperature right now minus 6. So the fatigues, the fuel authorities, the electronic control computers control the recirculation. We have the fuel transfer from the wing tanks and the center tank into the engines to heat it up in flight. Also the lubricant and the oil. We have the air pressurizer for hydraulic fluid tanks, oxygen pressurization. The doors are closed, the cabin can be pressurized, landing gear and the nozzle, pressure of tires and flight controls. You can see here the temperature of the tires. You can see also aileron spoilers, the flight controls movement, the rudder pedals, the tail, and the horizontal trim stabilizer. FS display over here. So this is one of the last things we need to know over here. FS display over here. Maintenance systems, circuit breakers, again system. So we go in the checklist. You can see last thing, before start, after start, descent, approach, landing in the flight. So we have also navigation display over here. So we need to turn off both engines very quickly. We're gonna make an engine auto start. So we have the fuel transfer to the off position like this. You will see what happens. We're gonna have fuel starvation from the engines. The engines are off. The message. So we look outside. So this is the engines are off. We need to restart them very quickly. We go in the overhead panel and set both auto start to the on position. So we have the reconfiguration number switches in the overhead when we turn on the auto start for the engines. So you can see we have the N2. We have pressurizer admitted from the APU into the N2 stage, which is the high pressure compressor and turbine, and the high speed starter and shaft of the engine. So you can see we have only pressurized air. So we need to start the fuel flow, the fuel valves very quickly. So we start the fuel valve, and the auto start will turn on. We have the auto start 25%. The N1 also, which is the low speed starters, have low pressure compressor and turbine with the turbofan 2% engine, exhaust gas temperature, fuel flow, principal oil pressure, oil temperature, quantity, and the vibration of the N2 stage of the engines. So we have the N2, which is the high speed starters have. Then we have the auto start is on, and we have the running engines over here. Both engines are running. We can go for takeoff. So we use flaps up over here, speed brakes arm. So we use over here also autopilot. We set the airspeed heading, the airspeed guidance over here. Flight director on and off. So we have LNAV and VNAV, turn on and off. Use the LNAV, auto throttle left and right like this. Autopilot disengage. The heading also, set the heading. For the runway we use for takeoff and for landing, same heading. Also the vertical speed over here you can set how many feet per minute you need to descend or climb like this, or level off, zeros. So we use climb for after takeoff. Also the altitude we need to reach over here. So we are ready for takeoff. Parking brakes off, advance the thrust levers. We take the air traffic control clearance to taxi into the runway, as you can see. So we use the tiller for the directional steering of the aircraft. So we taxi into position over here, as you can see. So we advance the thrust levers to full takeoff. Ready for takeoff. Side stick down, yoke down until 80 knots. So we have 100 knots, yoke up, 130 V1. We rotate over here, so we rotate like 9 degrees or less. And we have the takeoff, positive rate of climb, landing gear up. So you see the takeoff of the Boeing aircraft. Hope you like it. You can see the displays, what they read, the information. It's like in the original aircraft. We have the airspeed over here indicated 175 knots, the pitch altitude 20 degrees. We are 2,500 feet above the ground, but 4,000 above the sea level. Climb with 4,000 feet per minute. The stall speed, the wind direction and speed, the flight plan, the waypoint. We have the intercept, the terrain, red, green, yellow in the flight plan here also, as you can see. So also we have the engines indications. Also for the terrain, you can see here we have further away or closer up. So if you look closer, you will see we are just like 4,500 feet above the ground over here as we climb. You can see this green wave is the terrain below us. 4,000, 5,000 feet above the terrain. Here's the aircraft as we climb. So we need now look outside. We need to start the turn over here, going back to the flight plan. So here's the runway. So we start the turn here, going into this direction. This is a little bit left rudder for directional control. We can leave the hands off from the aircraft, no problem. It keeps flying the way it should be, as it is trained and has the thrust levers position to maneuver the aircraft right. So you can see the air data here. As we climb, we have to fly through the Zui. The airspeed now is a little bit lower as we climb. The engines also autopilot setting over here. So this is a very beautiful view of the Switzerland over here as we're flying the Boeing 787, as you can see. This beautiful jet aircraft. So we have the Switzerland view, the lakes over here, the Swiss Alps. Also the Germany, my homeland in front of you. We're gonna be overflying Germany, France. So we keep flying over here, keep climbing. So we need to overfly here the Zui as we cross through the waypoints. You can see also the other side, what we need to do. So you can see the aircraft inside just after takeoff. What you can see. The head-up display also. So we're gonna make some turn right now. Small turn like this. Use a little bit right rudder also for alignment with the flight plan over here, as you can see. So we have Nigria, the next waypoint we have to follow. The ground speed of the aircraft, the wind direction 25 knots. Also the other side flight plan over here. Also the outside view, if we look outside, you're having this beautiful view. So you have the France here. Also galactic view, the Germany, my homeland Bayern Munich in front of you. Gonna be overflying the lakes and the Switzerland. So we go for the turn here of the aircraft. We're gonna initiate a turn. So you can see we're turning right now. We have the attitude we need to have for the turn over here. and keep climbing. So this is the outside view as we're turning. The Boeing 787 model. So we are overflying the Germany here, Bayern Munich, the lakes, the France. So we are 20,800 feet. Need to align with the flight plan also, this line. So you can leave the hands off from the flight controls, no problem. So we keep altitude here in the flight level, climb a little bit more. Need to follow the flight plan. So we're gonna be having the chemtrails right now, frozen vapors over here. So this is the frozen vapors, also the view overflying the aircraft. This altitude we need to level it off now, you can see. So we're leveling off 23,400 feet, overflying here as you can see. Germany, the lakes, Switzerland, my homeland of Germany, and the France over here, galactic view. So hope you like the 787 view. So this is the most beautiful galactic view over here. So we need to start now the descent. Align here with the flight plan, initiate the descent. Flaps up. Speed brakes down. So here we are overflying this beautiful region, and we initiate the descent of the aircraft. So we overfly here the airport, idle thrust, idle thrust. You can see the view of the cockpit one more time as we are descending now. And we have 5 more minutes to descend, approach and land. We need to follow this plan, the purple line, as you can see, and now the other side, also the autopilot settings we have for approach and landing. So we may initiate the descent now, the turn, in a couple of minutes. Keep pushing the side stick down. Keep descending, 15,000. So we may start the turn now, if we need 14,000. So we use a little bit left rudder here for the turn. Keep descending, and we have 4 more minutes for the approach and landing. So make a left turn over here as we descend. And we have the runway in sight over here. So here we are descending. Increase the flaps for approach and landing as we descend. So here we are. Also use this view for approach and landing. So we need to increase the rate of descent a little bit. We are a little bit higher than we should. We have 2 more minutes for approach and landing over here. So we add a little bit more thrust. We have some wind gust, some side wind. We have the Lszh localizer here, the information we need to use for approach and landing. So some side wind, we use some flight controls, increase the thrust levers also. The engine's thrust power for approach and landing. So we use a little bit rudder pedal also, left rudder for this approach and landing. A bit less thrust now. Align with the center line, we have side wind, as you can see. Idle, thrust now. Keep descending. Align with the center line over here. So we have the approach and landing. Idle thrust. Touchdown. Very beautiful touchdown. Align with the center line. Also parking brakes and thrust, full thrust reverse over here. So we have full thrust reverse, and we're slowing down, as you can see. So this is how we slow down using the thrust reverse. As you can see, full thrust reverse. And here we are. You can see all landing gear part is safe. There is no breakage of any or any malfunction of the aircraft. You can see all landing gear. The nose wheel over here is perfectly safe. The landing gear behind it, the aircraft landed the way it should be over here in the runway. So we use the idle thrust reverse over here. The thrust reverse is locked. So that was